And in
That
your
is
role, did you have to? I'm guessing you had to work with a lot of customers as well. Yeah, that
uh,
brings memories
yeah.
to me as well in my role. But go
Oh, from where?
from everywhere. Pretty much eBay, people wouldn't trust AA results because if something showed off,
Yeah,
obviously the blame would be we don't trust the platform's randomization. There is bias involved in it. The problem
yeah,
was eBay used to have 0.1% alpha threshold. That's already too high. So, and there was another policy in place before my time, which is if you are running experiments for a smaller countries like any European
yeah,
country, um, like UK, Germany, they their intuition was it has much smaller user base, so
yeah,
we won't be able to get readout fast. So let's increase the alpha threshold even higher for non-US countries, okay, which is
yeah,
zero point 0.2. Now, just think about that. Two policies happening at the same
yeah,
time. And when an experiment was set up, it was set up across four different sites: US, UK, Germany, and I believe Italy or
yeah,
France, sorry. So, four sites. Three of them are being evaluated at point 0.2, and one of them is evaluated at point 0.1 threshold.
yeah,
And the KPI is same, but the the duration was always kept same for AA
yeah,
test. Now there are so many factors that go in this setup that
yeah,
one may not even understand the number of statistical traps that are laid out already in front of them. This is using frequentist method, right? So there are so many traps, which one is obviously two different alpha thresholds. That's already a
yeah,
big problem because now you're comparing different results of different magnitudes. Like US has sure much larger population, but no one cared to evaluate its coefficient of variation for
yeah,
the KPI for across the sites. When I came in, I showed straight up that the coefficient of variance for non-US sites is much lower.
yeah,
And what that does is it tells you actually that you can get faster readouts on those sites because the variance is so small and the
yeah,
population is, even though small, you're measuring a different amount of lift probably in that country, and given that
yeah,
MDE that you're trying to measure, you actually need less samples compared to even US, because in US you're trying to measure smaller lifts,
yeah,
has much higher coefficient of variation for that KPI. So
yeah,
it takes long time anyways. On top of that, the alpha is point 0.1. So all of these multiple things were happening at the same time, and I had to
yeah,
really convince them to change their threshold levels, so unify it. No one agreed to bringing it down to zero point zero 0.05, but
yeah,
everyone finally agreed to switching to zero point 0.1 for non-US sites as well, after I
yeah,
showed them the coefficient of variation and the duration it took for other countries to actually measure. So, but yeah, so that at least helped a lot in terms of AA. And I did actually a blind. So there were already past years AA tests. So the good part about one of the teams was they used to always run AA before they switched to AB. And I
yeah,
had 1 year's worth of AA test data from the past. I did meta analysis on those. And what I did is I did a blind study. Okay.
yeah,
I didn't tell anyone that this is AA data, and I just
yeah.
started to survey. And survey was very simple: pick the
Yeah.
winner based on the numbers that you see and the p values
Oh,
that you see.
yeah,
Okay, so everyone was showing me winners here and there, left and right, right, because of the data that was already available. And then I used to reveal that this is not an AB, this is AA. And then what
yeah,
I did, I applied the alpha threshold equivalence to the same data, like zero point 0.1 instead of zero point 0.1 and zero point 0.2. That
yeah,
already removed so many significant results from the picture because I reduced the alpha threshold. So now your p value under zero point 0.1. And the other
yeah,
thing I did is I added a multiple comparisons correction, two values. One is Bonferroni and the other is false discovery rate correction through
yeah,
FTR, false discovery PNH procedure.
yeah,
So, and then I showed them how the AA tests now look. And like there were like 20 something tests, and
Yeah.
4 different countries each. So I had like 20 times 4, like 80 results in
Yeah.
place. And previously there was like almost 60% false positives in AA results.
Oh
Okay.
my God. Yeah.
Yeah. And that's worse than a coin toss, to be honest,
Yeah.
right? So if you just
Yeah.
tossed a coin and made a decision, that would have been more efficient. And the other one was so after I unified the alpha, it dropped down straight to almost like 20% um, false
When
positive.
you say zero point 0.1 alpha, that's a 10% false positive rate or a
Yeah,
0.1%?
right.
10%
10,
false.
10,
Yeah.
10. No, not 0.
10.
That is too strict. 0.1. 0.01
Yeah.
is too strict. Yeah, it's zero point
Yeah.
0.1. Yeah,
Point.
so
Yeah.
still too high. Yeah, 1 in 10. So
That's quite huge.
yeah, and then
And I
after
think going to
Bonferroni,
hospital. Yeah.
yeah, after Bonferroni correction, it dropped all the way down to like 4% false
Yeah.
positive, which is acceptable because that's what you observe out of
Yeah.
80. That 4% is still way better. And then, but Bonferroni we know is too restrictive. So I applied
Yeah.
BH procedure, which increased it to like 7%, from
Yeah.
4% to 7%. But that's still under the unified alpha level of zero point 0.1, right?
Yeah.
So I showed them all of these different exercises that I did stepwise and eliminated all these false positives because the system is not designed currently to look for all of these, and the
Yeah.
policies were wrong. So yeah, that brought back your example of eroding trust on the from the experimentation platform. It just goes out because folks do not have good understanding of the statistical methods in place. And I think it's also good opportunity to design the scorecard or the
Yeah.
outcomes in such a way that they do not fall in those traps again. So that is what my entire work was after that exercise, which is
Yeah.
rebuilding the scorecard, and um, so that no one falls into those invisible traps unknowingly.
I think if you
Oh,
come
sorry.
from a computer science sort of a background, then
Oh,
Python
yeah,
is
true.
much more. Yeah.
True, true. You came from computer science to data science, so yeah, makes sense.
Yeah.
I came from basic data analysis, so SQL and
Yeah.
SQL only, to and SQL and Excel. And even in Excel, I learned brute force way the VBA coding or the
Yeah.
scripting side of it. And then I saw research community switching to R for ETL work. Not,
Yeah.
yeah, I mean, some amount of ETL work being done in R, including some of my colleagues. They were using R, but I still found comfort in SQL. And I learned a little bit of shell scripting in which I could loop through a code, like a SQL
Yeah.
code through shell scripts. So
Yeah.
I learned that. I still didn't use R looping or anything like that to extract the
Yeah.
same amount of value, or I didn't learn the what do you call variable format of SQL and stuff. I still continue to use basic SQL, have create some variables, but then pass the values through shell scripts in it. So and
Interesting.
it worked well, yeah, for my use cases. I never had to switch to Python or R for that matter for many years, even after graduation. Like almost 6 years or 7 years, I've not worked in Python or R or anything like that. I would
Yeah.
resort to shell scripting because shell scripting offers a lot of those functionalities, anyways, that Python and
Basic.
stuff have provide, at least basic stuff. Yeah, yeah. Sure, it's not efficient in terms of data structures and stuff like that, but so yeah, very bad in terms of computer science fundamentals, but still it gets the work done for my use cases.
Yeah. Yeah.
Yeah. The next one is p-value or confidence intervals. And I see this question asked often, like when they say p-value or confidence interval. Sometimes I wonder if these folks do not have that basic understanding that when p-value is under statistical significance threshold, that means your confidence interval will be one-sided, anyways,
Yeah.
on one sign, right? So either it will be all positive, both sides, upper and lower bounds, or both negative, upper and lower bound. If
Yeah.
your p-value is above 0.05, then there will be zero in the middle. So a lot
Yeah.
of times this understanding is not clear, and that is why there are such like debates about whether we should do p-value or they both pretty much tell you the same thing in terms of peaking anyways.
Yeah.
So your confidence interval would not have converged onto one direction. If they both show different, then there is something wrong in the stats engine itself.
Yeah. Yeah.
Somewhere your standard error calculation is messed up, and
Yeah.
your upper and lower bounds are showing you different than p values. So that is something that obviously you need to be careful about. The one good thing about confidence interval that I like is, me personally, I don't like people to just take the face value of the lift and go and show that in their presentation slides to leadership, right? Like,
Yeah.
this is the lift that we are going to observe. Like, no, that's not the lift you're going to observe.
Yeah.
95% chance that you're going to observe between this and that. And if you look
Yeah.
at the lower limit, and if it's positive, chances are the lower limit is 0 plus 0. Um,
Something.
0.05% maybe.
Yeah.
So, but you're quoting, let's say, if the confidence interval is wide, and let's say it goes from 0.05 to, let's say, 3%, you're
Yeah.
quoting the middle point of it in an exec meeting. And if you launch it, turns out it shows up at, in reality, to be right at the lower end of it. You're not going to see that
Yeah.
huge uplift that you promised in production, right? So it's always good idea to show the two limits under which someone can expect their um,
Uplifts to be in.
production of lips to be, right? So that is, and that is also at 95% confidence
Yeah.
interval. So chances are that may not even happen, and it would be neutral or nothing. So that's something that I definitely want folks to really understand. And the
Yeah.
other beautiful thing about confidence interval is, I don't know if you've seen that diagram where there is upper and lower bound from the middle line, and then you see there are five different cases. Sometimes the upper and lower bound is right here, sometimes it's right here, sometimes it's right
Yeah.
here, and then sometimes it's way too wide, sometimes it's on the other side. So all those five cases, right, if you can really understand well, then it will really tell you, like, if you're looking at MDE of X, then your lower
Yeah.
limit, if it's above your MDE, that means absolutely you are good to go, and you can quote
Yeah.
MDE in that case. That's fine, you observe that lift. But if your lower limit is under MDE, still positive, there is still a chance that you may not see that much lift, and you
The
are still
uplift.
quoting your observed lift, which is going to be higher than MDE, and that may
Yeah.
not even pan out. So that there are so many such cases where the lower bound is not higher than MDE, then uh,
Yeah.
in production version it's just flat performance pretty much. So yeah, so there is some lack of awareness about those cases. And I think experimentation platforms should do a really good job of showing that out.
Yes.
um,
Yes.
but the visual occupies a lot of space as well. So
Yeah.
that's something that absolutely is something that the developers can work on, and or UX designers should work on, and figuring out like which is absolute a winner, which is a
Yeah.
winner with a grain of salt. Even though p value and everything shows positive, there is still a chance that because your lower bound is under MDE, mm,
Yeah.
something else can happen. So
I
yeah.
think it cannot be entirely reduced. Like, I personally think one very underrated idea in statistics is that basically you this proportion of good ideas and bad ideas that you are having, like if for the metric you are testing and for the page you are testing, it is very normal to see 5 to 7% uplifts. Then maybe if you have gotten a 5 to 7% uplift, it might be true. But if normally the uplifts are only in the 1 to 2% range, and you get a 5% uplift, then it is most likely like sort of a fluke. So
Mm.
I personally think what I call these is the priors, and because no one knows
Yeah.
how to define priors, there is no absolute science to define that this uplift can be
Yeah.
expected and not be. So yeah,
Right. Yeah, the MDE value itself is a hard number to get to. um,
yeah, definitely,
yeah.
definitely. I think,
Yeah.
yeah.
The next one is most underrated statistical concept.
I personally think I find this one idea very interesting. I think the world needs to understand these extremist and variables much better. So yeah,
Right. I used to deal with revenue at eBay, and
yeah,
that was the North Star metric, and extremely right skewed. Even
yeah,
after Windsorization and everything, we would have a range of a
yeah,
dollar to $8,000 after removing the some of the categories. So we already excluded like business and industrial transactions, because there the
yeah,
machines are being sold for 100, $200,000. We don't want that in our data anyways, and we are not optimizing the experience for them. We remove all real estate transactions. We excluded all of the other automobile transactions. So eBay Motors was never considered as part of core eBay. So we
Yeah.
excluded all of those as well.
Yeah.
Apparently, Mark Cuban purchased a yacht through eBay. That was
Yeah.
a kind of a rumor. I don't know how true that is, but that was in seven figures. And
Yeah.
that obviously skews. So we excluded all such transactions out, right?
Yeah.
And we only look at a few core categories. Even then, the skew was that wide.
Very
So
strong.
up to
Yeah.
8,000 after winterization.
Yeah.
So yeah, it was a chaotic KPI, but
Yeah.
everyone wanted to measure that, so we had to come up with so many different ways to reduce its variance or surrogate KPIs. KPI engineering is itself like a, I think it's a job of a product analyst or an experimentation data scientist, because if you're trying to measure its lift, you need to understand its metadata structure of the KPI itself, right? Like the
Yeah.
same KPI would have a different distribution if you look at it differently. Like we used to observe revenue per user, but if we did revenue per session, maybe it might have a different spread, right?
Yeah.
So,
Yeah.
so all those things definitely need to be considered in designing that specific KPI for the very specific purpose. Um, like, is it for A/B testing, or is it for, I don't know, churn modeling or whatnot, right? So you need to understand the context and then use that KPI for, or design that KPI and build a pipeline around that. I
Yeah.
think that is one most underrated statistical concept that I have, which is most folks just take the KPI at face value.
Yeah.
So we'll go with watch time. So they'll just take average watch time, winsorize it, and get done with it.
Yeah.
But there are different ways to approach. In what context are you trying to optimize it? Is it within a session, or is it within for the entire users present throughout the experiment? Right. So yeah, all those contexts get lost, and when it comes to hypothesis, and of course there is this whole debate of categorizing a continuous variable versus not
Yeah.
categorizing a continuous variable. But sometimes categorizing did work well for us, because
Yeah.
categorization, so like we would have GMV in X to Y range, Y to Z range, Z to A range, right?
Yeah.
So that way we know which box moved the lift. The other alternative is just doing a quantile regression, right? So it's
Yeah.
a slightly more involved method where every single percentile value is combined with every other percentile in treatment and control, and you can see how the
The-
curve looks of the lift. So every
Yeah.
quad, like initial first few might have a jump, then it might drop, and then it might go up. It tells you how different users, like different segments of users, are engaging with this specific feature. So
But doesn't it leave the bins with very less data, or that was not a problem in like larger companies? Like the
yeah, so we
different
didn't have that.
quantiles.
Yeah,
Yeah.
each quartile would have lots and lots of users anyway. So
Okay.
yeah,
Okay. Yeah.
yeah, and it's doing a regression. It's not even standard A/B like t-test comparison.
Yeah.
So
Yeah.
it does a quantile regression. It has a different library as well within Python for doing that.
Yeah.
But it's tough. Like it's not easy to productionize. You can do it offline mode.
We
Yeah,
did
cool.
dive into quantile regression, but yeah, for us, the major issue was sample size. I think you
All
were on
right.
the luxurious side for having visitors. I think. Yeah.
At Apple, we had no shortage of users. Let's just say at Apple, one of my teammates used to help App Store exclusively, and there are users like 500, like active Apple devices. There are like 2 billion plus devices active,
Oh God. Oh God. Yeah.
and each of these devices have App Store. And when someone opens an App Store to download something, you
Yeah.
have those sessions coming in.
Yeah.
So there would be like 500 million at any month,
Month.
anyways, pretty much open the app. So it's insane.
It's insane. It's really, really insane. Yeah. Yeah.
Next one is most overused KPI in experimentation.
So I think from my perspective, so that's somewhere I do not have context. But what do you think? I'm curious to know your answer on that.
I mean, it's either one or the other variant anyway. So conversion rate is, I would consider like any binomial KPI. So that's pretty common. But I didn't see that being used as frequently in any of my past roles, except I would say at Peacock, where one of the team growth,
Yeah.
their goal was conversion rate, because either they would work on folks purchasing a subscription,
Yeah.
or them running an experiment that preventing a churn. Like instead of canceling the subscription, they would accept another lower tier plan, something like that. So that
Interesting.
was, yeah, so that was one use case of binomial, but most essentially everywhere else they would use continuous. So at Apple it was good play duration as well as good play rate. So this was,
Yeah.
but at Apple it was session based. Even though
Yeah.
users were randomized, so there was some correction that was done over there. Peacock, every other view related KPIs or experiments was watch time, average watch time. eBay GMV, uh, and
GMV is gross.
gross merchandise volume, which is
Yeah.
total average per user. That is, so when I say revenue per user, right? In my
Yeah.
previous thing, is actually GMV, like how much total amount did they purchase?
Interesting.
Yeah, so that was
Yeah.
at eBay. At Yahoo, it was searches per user. Again, a continuous but still well-defined continuous. There is some structure to it, like whole numbers in the numerator, pretty much, but it still had problems because some users would search way more often than others. So, but
Yeah.
much less issue compared to eBay's GMV because the
Yeah.
coefficient of variance would be much lower.
Yeah, I think that is one of the problems I've heard even a few other experimenters talk about. When you go into a revenue sort of a metric, it's again just such high variance and such extreme stance out of a variable. So yeah, a lot of
Yeah.
problems there.
Yep.
So, yeah.
Yep.